fourth video, we are going to focus on one of the functions that is not on the slide, so consider this as a hidden track, your bonus track if you will. We have our next functions are going to be concerned with manipulating strings to clone them, gather two strings, which is pretty much make a copy of two strings into a bigger one, and extract a substring from a string. Before to do that, I'm going to come back here and I'm going to complement the work we did with strallocate to write a deallocate function. So we're going to go back to our code. Here we are. strallocate is right here. Instead of using free, I'm going to write my own version of free pretty much. So let's go for it. Void strdeallocate, and I'm going to start by taking a pointer p, char star p. Here's the body of my function, and I'm going to go up there to fill in the declaration. Okay, so we can now deallocate pointers. So I'm going to use it deallocate right here instead of the free. How do I write this? Well, the first obvious way to write this kind of function is to use free. So you call strdeallocate. Behind the scene, I'm using simply free on your parameter, and this is it. Well, that would work. However, if we rewrite our own deallocation function, we might want to do something extra. Okay, so what I suggest we do is, instead of simply deallocating whatever is pointed by p, which is what we allocated previously, we are going to deallocate it and set the pointer p to null. Clean programming practice call for you to assign the constant null once you are done deallocating a pointer. That spares you to later on try to dereference this pointer that still contain the address of a chunk of memory that you allocated and deallocated previously. If you do so, you are going to cause problems, not necessarily problems that are going to be immediately obvious. So this is a very insidious type of bug to have to track, and can be really time consuming. So instead of having to track that kind of stuff, as soon as you free a pointer, you assign it to null. As soon as you try to use it afterward, it crashes cleanly. Okay, and you can identify easily which pointer is at fault and what part of your program did a boo-boo. So what we want to do with our string deallocate is, instead of having to write p is assigned null afterward by ourselves, we want to do it inside of the function itself. So here's the first proposition. Okay, I free p and I assign null to p. Problem with this: p is here local variable, a stack variable for the function strdeallocate. So I can act on what this variable is referring to. This is what I do with free, and this is going to affect what is pointed. However, if I change the value of p, this is not parameter passing by reference anymore. I'm just modifying the value of a stack variable, local stack variable, and this is not going to affect the main. So I have, in this case, the same name for the pointer p in the main and this parameter here. Let me change this real quick so that I dissipate any confusion that this might involve. So I have now two different names. There is no more confusion. My point is that when I modify x in this function, I'm not modifying the p variable, the p local variable of the main. How can I modify the p local variable of the main? I need to pass it by reference. So I need to pass the address of my variable p if I want this function to be able to modify this variable p. However, right now my parameter is a pointer on char. What is the type of the expression address of p? Well, let's see. P is a pointer on char. The address of a pointer on char is a pointer on a pointer on char. So there is double dereferencing that will need to be involved somewhere here. Well, first I need to declare my parameter as being a pointer on char. That will allow me to accept the address of p here as parameter. Inside of the body of my function, now when I try to free p, I need to dereference first x. Dereference x is going to lead me to the variable p. Okay, and when I call free with as parameter the content of the variable p, I'm effectively deallocating my memory. When I do x is assigned null, same thing here. I mean to talk about the pointer p from the main, the pointer variable which address was passed to me when calling strdeallocate. So this is going to be like dereference x equal null, which is going to assign null to, in this instance, the variable p from the main. Let's compile. Once again, this is not going to be spectacular because we are not really doing anything with this memory. We just make sure that it allocates and deallocate. And as I said previously, for a serious testing environment, that would call for a little bit more work. Well, we won't even have to go to the testing. Apparently, there are a couple of syntax errors. So gcc main.c, line 32, passing arg number 1 of str deallocate, incompatible pointer type. So let's go have a look at line 32. When we are invoking str deallocate, we are passing the address of p. This is making sense with what is defined here. However, it's not making sense with what is declared here. So when I updated the definition of the function, I didn't update its declaration, and we have here a little opening curly brace that could suffer from going away. Otherwise, this is going to confuse also our compiler. So we just fixed 2 bugs in the source code file. Go back to our terminal, compiles fine now, try to execute it, it runs. Like I said, okay, this is not like a serious testing, but at least it's showing to us that this little function here is written correctly, and I can guarantee you that this is actually working correctly. Okay, and we are done with this hidden track.